6x minus 14 equals negative 3. Ooh, boy. Negative 3x plus 22?
Yeah.
Now, Janellis, here's the tough part. Why are those two equal to each other? You can check by your chair. And LG are all the same length, okay? So you can put little congruence marks on all of those because this is the in-center. So once we know that this is the in-center, we set up our equation. Janellis, you can continue.
Okay, so then I did plus 14 on both sides.
Mm-hmm.
And then I did plus 3 on both sides.
Not just 3.
3x.
3x.
And then I got 9x equals 6.
Okay, keep going.
4, we divide them.
Mm-hmm.
And then I went back to the first equation, the 6x minus 14.
Yep.
And plugged in the 4.
Beautiful.
Got 10.
So you got 6 times 4 minus 14. You should have gotten 24 minus 14. And you would have gotten that this is 10. So the length of your side was 10 for MG and NG. What's LG? 10 as well, okay? All three of them should have been 10. Mariana? Did you have a question?
Do you not have to plug it into both equations?
No, because as long as you know one of them is 10, the rest of them have to be 10. If you wanted to plug it in and check that they both equal 10, you can go ahead and do that.
Yeah,
Giselle?
that was my question. Like, what if you don't know for sure if x is 4, then you could plug it into both to make sure.
Yep. So if you got x equals 4 and you plug it back in and you get different values for both, what's wrong?
This
The x value is wrong, okay? Then you would go back and recalculate it, okay? So it's actually a great method to check your work at the very end, okay? What about number 6? Now, number 6, okay? I personally don't particularly like this question because it doesn't tell you that they're bisectors, right? It just shows that they're perpendicular, okay? So how I would have liked number 6, and you guys can go ahead and add this in there, is that each of them are perpendicular bisectors. So just add little congruence marks on both sides of each of the bisectors. Now, what is the point G? Savannah?
The point G? Oh, was the in-center.
It's not the in-center.
The circumcenter.
It's the circumcenter. Why is it now the circumcenter and not the in-center?
Because it's coming off from the, I don't know.
Dylan?
Is it because it's outside the triangle?
That's one reason, because an in-center always has to be inside. A circumcenter can be outside. So that's one reason. It's outside the triangle. What else? Giselle?
It's coming out from the vertices, or from the sides.
Where does the circumcenter, where does it happen? Christian?
Both the angle bisectors meet up at that point.
No. It's not the intersection of all the angle bisectors.
But isn't that
Oh, wait.
It's the intersection of what?
Of the sides.
What do we call these peeps?
That's what I said. Or no,
Perpendicular bisectors, okay? It's where all your perpendicular
I meant that.
bisectors meet. Okay, I'm going to be real with you guys. If you guys don't know this for your test coming up on Thursday, you're going to be in a lot of trouble, okay? Now, there is a slide in these notes that breaks it all down. It's like a summary slide. That one you need to study and have memorized, okay? And when we get there, I will point it out, okay? So we know that it's a circumcenter. It's perpendicular to all the bisectors. So all of the lengths from G to the vertices, so GJ, GL, and GK are all what? They're all the same. So this is congruent to this, which is congruent to this. Actually, let's add 4 marks because we already used the first 3.
Oh, yeah, that's what I did. I said that G. and J or GJ was 2x plus 8.
Yep. GJ equals GL, which equals GK. Now, we're given 3 of them. We just need to use 2, right? So let's just say, okay, 4x minus 2 equals, can we use GE? No, because that one's not one that's congruent. That's one of our perpendicular bisectors. So we have to set it equal to GK, which is 2x plus 8. You would subtract 2x minus 2x. You would get 2x minus 2 equals 8. Add 2, and you get 2x equals 10. So x equals 5. Once we have that, we have to find GJ and GE. So GJ, you just plug it in. You get 4 times 5 minus 2, which is going to give you 18, which is GJ. And then plug it into GE, which is 3x plus 2. 3 times 5 plus 2 equals GE. So then we get 15 plus 2, which is 17, equals GE. Are those supposed to be equal? No. Okay, because GE is a perpendicular bisector. GJ was the distance from the circumcenter to a vertex.
Wait, so why didn't we set it equal originally?
Yeah, so we had to figure out what x was.
So that's why you said it equal, but not because they're actually equal.
They are equal. But I used GJ and GK, not GE.
But why? Like, can you use either one?
No. Guys, you have to, this is a question that would throw most of you off from our Chapter 6, Section 3, Medians and Altitudes of Triangles. So, we talked about perpendicular bisectors. We talked about angle bisectors. Now, this chapter is going to talk about, or this section is going to talk about medians and altitudes. And where all of those meet is going to be a different point as well. Okay? So, a median of a triangle. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So, for example, your median starts at the midpoint of the side AB, and it goes to the vertex C. Every triangle has 3 medians, and the medians are concurrent. That means that they all meet at one point. So, let's go ahead and try to draw the median, starting at the midpoint of CB. So draw a point around the middle of CB. Where should that point connect to? To A, the vertex on the other side. And then lastly, we're going to draw the midpoint of AC and connect that to what? To B. And if you did it right, they should approximately, now we're not perfect, they should arrive all at the same point. That point, we'll find out what it's called, okay? But those are each of the medians. So, if all those red lines are medians, guys, what other segments are congruent? Let's label this E, point E, and let's label this F. Emma, what are 2 congruent segments?
AF and CF.
Very good. AF and CF. Because a median, right, has to start from the midpoint and go to the opposite vertex. What would be the last set of congruent segments? Mariana? Very good. CE and BE. Moving on, that point where all of them intersect, we call that our centroid, okay? It's the point of concurrency of the medians of a triangle, okay? The centroid, like the incenter, is always, underline, highlight, do something to always, it's always located inside the triangle, okay? Now, do you remember how the circumcenter was the same distance from each vertex? The incenter was the same distance from each of the sides of the triangle? The centroid is also called the center of gravity. It's the point where a triangular region will balance. You guys need to know that for your test, okay? It's the center of gravity. So, if you were to take any triangle and put a pencil where the pencil's eraser was located at the centroid, that triangle would balance perfectly on that pencil, okay? So this point right here in our diagram is our centroid. So, three things you need to know. Your centroid is where all the medians intersect. It's always inside the triangle, and it's also called the center of gravity. It's the point where the triangular region will balance.
Wait, it's where all of the medians are?
Yep, where all the medians meet. Why is a centroid similar to an incenter? What's their one similarity? Always inside the triangle. Very good. The centroid theorem, okay? So the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So the medians of ABC meet at point P. Therefore, point P becomes my centroid. Put a little dot at point P, draw a little arrow, and say that this is your centroid. Okay? Because it's where all of the medians meet. So if they all meet at P, then look what happens. AP, okay, that's this distance right here, is going to be 2/3 the distance of the entire segment AE. Okay? So AP is 2/3 the distance of AE. BP is 2/3 the distance of BF. And lastly, CP is 2/3 the distance of CD. Now, I'm going to walk you guys through this, okay? So, the centroid theorem says, okay, each of these segments, B, F, A, E, and DC are all medians. You guys with me on that, okay? They start at the midpoint of a side and they go to a vertex. You guys agree with that? Okay? Now, the point where they meet is called our centroid, and it splits each of those medians into two different parts, and they have a ratio, okay? The longer side is going to be 2/3 of the entire length of the whole thing. So the smaller side, guess how much this is? 1/3, right? So this is going to be 2/3. This is going to be 1/3 of the whole thing. This is going to be 1/3. This is going to be 2/3, right? Okay? So they all have the same ratio, okay? Now, are all the medians the same length?
No.
No, okay? But they all follow this ratio, okay? So if the entire length of AE, I want you guys to write this down. If the entire length of AE, if AE equals 18, right? Take that 18 and think about it as being divided by 3, right? What's 18 divided by 3? 6. Okay, so we have 6 units. We have 3 parts of 6 units. What would the distance from A to P be? 12. Because it's 2/3 the whole thing, right? You can think about it as AP equals 2/3 times the whole distance, which is 18, which is going to give you 12. What would the distance of PE be?
6.
It's 6. Do you see how this is the 1/3 section? It's the smaller section. So this is going to be 1/3 times 18, which is just 18 divided by 3, which is just 6. All right. Let's say that DC was equal to 21. Let's say DC was equal to 21. So we want to figure out, okay, what would DP be? And what would PC be?
Can you make them up all these? Like
DC equals 21.
Yep, I'm making them up. This isn't given to you, okay? But you would be given AE equals 18, or you would be given DC equals 21, okay? Now we're gonna be asked, okay, what is DP? Is that the 1/3 or the 2/3?
1/3.
It's 1/3. What's 1/3 of 21? 7. And what does PC have to be?
The 2/3.
14. Wouldn't 7 plus 14, shouldn't they add up to 21?
Yeah.
Do they add up to 21? Yeah, okay. Let's do one more. Let's say BF equals 30. What would BP be? Giselle?
It would be
20. And what would PF be? 10. Okay? Now, sometimes it's not going to be obvious which one's the shorter and which one's the longer length, right? The longer length will always be from the centroid to the vertex. The shorter length will always be from the centroid to the side. Do you guys see that?
Yeah.
From the centroid to the side is small. From the centroid to the side is small. From the centroid to the vertex is large. From the centroid to the vertex is large. Dylan?
That this 2/3 isn't always the same. This is just what they're saying. This or is it always 2/3?
It's always 2/3 if it's the centroid, okay? But do you see how the distances of the medians changed?
Okay.
That's what I'm saying will change. See how it was 18, 21, and 30?
But either way, the long one would always be 2/3.
Correct. Yep.
Would you repeat the question?
We have to use that information, that it's the centroid, to help us find LS and NQ. Now it says RL is 21. So RL, this whole thing, is 21. What is LS?
14.
Very good. It's 14, okay? So LS has to be equal to 2/3 what the full length was, which is RL. And we know RL is 21, right? So then it's 2/3 times 21, which is just 14. Or I like to think about it, divide that number by 3. Divide the whole length by 3, then you figure out, okay, it's 21. And then you just multiply it by 2, because it's 2/3 of the whole thing. Like that. You guys are just like very visual, and you're like, if that's 4, then I just multiply it by 3. That's fine, okay? But when it does come down to like equations, you're gonna have to know the ratios, okay? Multiplying stuff by 2/3, multiplying stuff by 1/3.
Do you have to write out on the test like the individual stuff?
Wait, yeah?
Nope. Coordinate problems. Okay, a sculptor is shaping a triangular piece of iron that will balance on the point of a cone. Notice how it says balance, okay? At what coordinates will the triangular region balance? What are we trying to find? The centroid, okay? Now, all you have to do is find the midpoint of each side and connect it with the vertex. And then all of them will meet at your centroid, okay? So let's do it. What's going to be the midpoint of this side from 6,6 to 10,7? Well, let's go ahead and calculate it. The midpoint is going to be, how do I find the midpoint, guys?
Wait, can we just like count it? You do like this?
No, you can't count it. You cannot count it.
No.
Nope. Yeah.
You count how it goes horizontally, which is 4, and then you count how it goes vertically.
Nope. Nope. Yeah.
You use a midpoint by adding the both x points together and dividing it by 2, and then adding the y points together and adding it.
Excellent. So we have to add 6 and 10 and divide by 2 because those are our x coordinates, and add our 6 and our 7 and divide by 2 and get our y coordinates. It's x1 plus x2 over 2, and then y1 plus y2 over 2, okay? So once we add those together, we're going to get 16 over 2, and we're going to get 13 over 2. Let's change those into mixed numbers so it's easier for us to see. 16 over 2 is just 8, and 13 over 2 is just 6.5, right? So let's go over 8 units and up 6.5, and that should be a point on our graph. Is it?
Yeah.
Yes, okay? Now, take a line and connect that to what? The vertex opposite it. So take a line and just draw it vertically all the way down. Remember, your centroid is going to lie on that line, okay? Because that's our median. You guys with me on that one? Okay, so we finished one of them. Let's do another one. Let's do one in blue, okay? And let's do this side's midpoint and then median. Don't count it. Trust me. They're not all going to be this easy, okay? So let's go ahead and find the midpoint, which is going to be 6 plus 8 now over 2. And it's going to be 6 plus 2 over 2. 6 plus 8 is going to give me 14 over 2. And then 6 plus 2 is going to give me 8 over 2. So my 2 points, or my point, is now 7, comma, 6. So move to the right 7 units. Oh, thank you. It's 4. You're right. Thank you, guys. 7, comma, 4. So I move to the right 7 units, up 4. Does that look like our midpoint?
Yeah.
Where do I draw the connection to the other vertex? So draw all the way to the other vertex. Ah, do we kind of see where our centroid is?
Yeah.
Let's do the last point just for safekeeping, okay, to make sure that we did it right. Let's do it in green. Okay, so our last midpoint is going to be what? You guys help me out. Ten plus 8 over 2. And my y coordinate? 7 plus 2 over 2. Perfect. So I'm going to get 10 plus 8 is 18 over 2. And then 7 plus 2 is 9 over 2. So this is going to be 9, comma 4.5 or 4 1/2. So move to the right 9 units and then go up 4.5 units, and you should get right here. Where do all these medians meet? At the centroid. And what coordinate is that? 8, comma 5. So your centroid is at 8, comma 5. These aren't so bad, right? Christian, what's up? Yes, technically, guys, you only have to do 2. Why would I want to do the third one? Just to make sure, right? But the third one is automatically, as long as you didn't mess anything up, it will automatically go through the last, or the same point, okay? I just do the third one as safekeeping. Yeah, Dylan?
Is this not the same thing as circumcenter?
How is this different from the circumcenter? Through a triangular park. Each path goes through the midpoint of one edge to the opposite corner. The paths meet at point P. What does point P become? Based on that description, what does point P become? The centroid. So draw a little circle, draw a little dot, and label that your centroid. That's really tough to see. No. Centroid.
I recommend using a very light color.
All right, so if this is our centroid, guys, it wants us to find 1, 2, and 3. So 1, 2, and 3 are completely different questions, okay? So treat them as separate problems. PS and PC, when SC is 2,100 feet. So SC is 2,100 feet. What would PS be? Xavier? 700. So PS is going to be 1/3 of the whole thing, which is SC. You guys agree? So that's 1/3 of 2,100 feet, which is just 700. PC is going to be what portion of SC? Zoe? 2/3. So it's 2/3 of SC, which is going to be 2/3 of 2,100, which is 1,400. Now, how could we check that we did it right? What should PS and PC add up to? 2,100. Do they add up to 2,100? Yep. Let's do number 2. For number 2, it says TC and BC are what? When BT equals 1,000. So, B wants TC.
It's 1,000.
Now, be careful here. What is BT?
1,000.
But it's not a median, is it? It's not even part of a median. Do you see how BT is this side right here? If that's 1,000, how does that help us?
It's saying that TC is also.
TC also has to be 1,000. Why?
Because C is.
It's bisected. Very good. So this also has to be 1,000. Okay? So TC equals 1,000. Because they're equal, BT must be equal to TC because of the definition of a median. And then what is BC, guys? 2,000. Okay? You're just adding them both together. Okay? All right, now it says PA is equal, or I'm sorry, we need to find PA and TA when PT equals 8,000 feet. I'm sorry, 800 feet. So for the third one, PT equals 800. So this segment right here is 800 feet. What would PA be? Well, PA is going to be 2/3 of what?
2/3 of 800.
Of TA. So it would make more sense for us to find TA first, right? And TA is going to be PT times what? 3.
TA is 2,400 and then PA is.
So TA is going to be 2,400 because it's 3 times 800. And then we just use that to find PA. So PA would be 2/3 times 2,400, which would just be PA equals 1,600. Now, does anyone notice a pattern between the smaller segment and the larger segment of each median?
Oh, the smaller segment is the interior, and the larger segment of the second. That might sound wrong, but it is. It's like.
So remember, PT was 800, PA was 1,600. SP was what?
It's double this.
Do we see that? SP was 700 and PC was 1,400.
It's just double.
It's double. Do you guys see that? The smaller segment is going to be half of the larger segment, right? Because it's 2/3 of the part, 2/3 of the whole, and 1/3 of the whole. So do you see how 800 is half of 1,600? And 700 is half of 1,400?
Yeah.
Okay? The more you guys see these, the more you're going to notice, okay, this smaller segment has to be half of the bigger segment.
Always or just in this situation?
Always. Okay?
Wait, can you scroll down?
Segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. Do you guys remember back probably in middle school when you guys would calculate the area of a triangle?
No.
And you would have to draw, like, you would have to draw the height, right? Because the height sometimes would be like a slanted thing, okay? The altitude is just the height. It's the height of your triangle, okay? So if you want to draw a little note to yourself, okay? The altitude is the same as the height. Okay? It's just how tall your triangle is, okay? So those are 2 examples of altitudes, those red lines, okay? Notice how the altitude goes straight from that vertex down to the bottom where the base is, and it helps if your base is flat. Notice how PR, that side, is flat in both those instances. It helps to draw your altitude when this is flat. When this is flat. Okay? When your second side is flat.
What if it's not flat?
What?
What if it's not flat?
It just makes your altitude harder to draw. Okay?
But isn't it just a straight line? Other than the
Mr. Yurko,
Yep.
heads up, we have 10 minutes.
Okay, thank you.
Oh my gosh, you have 10 minutes already? That went by so fast. Are we supposed to like
Or is this just like?
Okay, turn your iPad to where P now becomes the top vertex, okay? Turn your iPad to where P now becomes the top vertex. Now, take a red pen and draw a perpendicular line down from P to QR. Okay? So make QR your base. In other words, put QR at the bottom of your iPad and draw the line down from P down to QR. I can't flip it for you guys.
Yeah, okay, but you get what I'm trying to say.
Yep. Then turn it again to where R is now at the top of your iPad. And then start your pen at R and draw it all the way down to QR. To QP. They should all kind of intersect at the same spot. What do we call that? That's your Ortho Center. Okay? I know, there's 3 of them that you guys need to know. Okay, now let's do the same thing. Let's scroll over to this next one. Okay, so Q we drew where PR was flat. Turn your iPad so QR is now the base and P is at the top. Turn your iPad so QR is now your base and P is at the top. Take a red pen, start at P, and draw it down to your base, which is QR. Uh-oh.
Wait.
Do you guys notice anything?
I don't know what you're saying.
Wait, hold on.
Did you guys turn your iPads to where QR is your base? Okay? You may have to lock your screen for those of you where
It doesn't exist.
is it going to intersect based on this line? Does it intersect our other red line? No. So extend it further. Extend it further. And then extend the other one.
How do you know which way the right hand?
Okay, and then we have to do the last one. So make PQ your base. Make PQ your base. Start at R. Now you may have to extend PQ visually with a dotted line, but start at R and draw a perpendicular line to PQ.
What? Wait, so it should look like this? I got it now.
The instructions. You have to turn your iPad 2 times, okay? It gave you 1 altitude. You had to turn your iPad 2 times and make different sides your base, okay? Start at the other vertex and draw a line straight down that's perpendicular to the base. And that's going to create your altitude. Now, notice the second triangle is obtuse, right? Where did our orthocenter lie? Outside the triangle. So we treat this one just like the circumcenter, right? Because circumcenters could lie outside the triangle as well. Do you guys remember that? Yeah. Okay. So your orthocenter is the point that contains all of the altitudes of the triangle. Okay? So all of the altitudes of the triangle are going to intersect at a point of concurrency called your orthocenter. Okay?
When's the quiz on this?
Wait, how is there more than one?
So your orthocenter is where all three of your altitudes meet. If it's an acute triangle, it's going to lie inside. If it's a right triangle, it's going to lie on your triangle. And if it's outside your triangle, or if it's obtuse, then it's going to lie outside your triangle. Okay? Okay? So go back to that example. It says find the orthocenter of XYZ with vertices -3, -4, -3, 4, and 5, 4. Okay? So let's just go ahead and plot those points. Let's see what kind of triangle we get. -3, -4 is down here. -3, +4 is up here. And 5, 4 is right here. This is Z, this is Y, and this is X. When I connect them, guys, what do you notice about the triangle? It's a right triangle. So it's asking us for the orthocenter. Right off the bat, guys, where's our orthocenter going to lie?
It's going to lie on this right. Did you put a letter for that? On Y.
On Y, okay, at this point. Now, let's check it, okay? Let's check it. We know it's going to lie on the triangle because it's a right triangle. Do you guys agree? Okay. But let's go ahead, turn your iPad so that XY becomes your base. Turn your iPad so that XY becomes your base. And then start at Z and draw a line straight down. Should go all the way along the side, ZY. Agreed? Okay. Turn your iPad again so that now YZ is your base. Start at X and draw a line straight down XY. Is that our altitude? Sure is. Where do those two altitudes meet? At point Y. Very good. So this is our orthocenter. And just to be perfect, oh, I wrote that upside down. Hold on. I keep turning my iPad, so I keep writing upside down. This is now, here we go, orthocenter. Okay? Just to be picky, like Mr. Yurko is, make XY your base, start at Y, and draw a line straight down to the base of your rectangle, or the base of your triangle as an altitude. Does that point also go through the orthocenter? Or does that line also go through the orthocenter? Yes. Sure does, okay? So your orthocenter is Y, and Y's coordinates were -3, +4.
For like when you draw the right angle, can it be on either side or does it have to be on like the right side that you draw like the little angle?
Say that one more time.
Like you know the
Straight up from the
So jump over 2 slides. Again, acute triangles lies inside. On a right triangle, it's going to lie always at that point P. And for an obtuse triangle, it's going to lie outside your triangle.
so it's like the other one.
Yeah. It's like the circumcenter.
So it's like a sister with circumcenter.
Yeah. It's like a sister.
Wait, what's the point of the
What?
orthocenter?
I'm not going to help you with that. You should know the difference between this and a circumcenter.
But this is the altitude difference.
Yep. And the other one is?
And the other one is perpendicular.
Thank you, Giselle. Okay? All right.
I'm sorry.
Now,
Unnecessarily loud. I'm so sorry.
is the orthocenter always located in the interior of a triangle? No. No. Okay? And this is where we're going to stop for today. So this slide, okay, this is a great slide to create flashcards from, to study, okay? Write a note for yourself. This is a great slide to study. Everything on this slide needs to get memorized before Thursday, okay? You need to know what forms a circumcenter, where a circumcenter can lie, and what a circumcenter means. And it is the same distance from all the vertexes. You need to know what forms an incenter. It's formed by the angle bisectors. You need to know that an incenter is the same distance from all of the sides of the triangle. And you need to know what it looks like in a diagram. You need to know that a centroid is the intersection of all the medians. You need to know what a median is. You need to know that the median, every median, is cut by the centroid into two parts. One is 2/3, the longer side, and one is 1/3, the shorter section. Okay? You need to know what it looks like in a diagram. And then you also need to know that the orthocenter is the altitude. Okay? It's where all three of the altitudes intersect. Now, the orthocenter is the only one that you won't be able to be given a problem where like there's values on it, right? The only thing I can ask you for the orthocenter, if you want to put a little star next to it, is I'll only ask you to find the orthocenter, okay? And you'll have to graph it, okay? And I'm going to show you an example where you're going to have to graph the orthocenter. It's much easier than you think it is, okay? In exercises 23 through 26, let's draw the indicated triangle and find if it's centroid and orthocenter. Okay? So for 23, we're going to draw an isosceles right triangle, and we're going to find the centroid and the orthocenter. Okay? So isosceles and right triangle means that two of the sides need to be the same length. So let's draw two sides that form a right angle and need to be the same length. Doesn't have to be perfect. And then the hypotenuse. This is 23. Okay, so the centroid would be connect all of the medians. So start in the middle of this side, connect to this vertex. Start in the middle of this side, connect to this vertex. And start in the middle of this side and connect to this vertex. Okay? The centroid lies inside or outside the triangle?
Inside.
Inside. Should it be inside?
Yeah.
Yes. Okay? So this is our centroid. And then let's find all of the altitudes of our triangle. So remember, for the orthocenter, it's where all of the altitudes meet. And you're going to have to turn this triangle around to figure out the altitudes. Leave it straight up and down, okay? Start at your top vertex and draw a line down to the base. You should notice that that line goes along one of the sides of the triangle. Do you see how the altitude is just this line right here? This blue line that I draw? Next, turn your iPad so that this, if you guys look at my screen, okay, this is the top vertex, okay? Turn your iPad so this is the top vertex, okay? And then start your point at that vertex and draw a line down along that side of the triangle. Where do they meet? They meet at the point of the right angle, okay? Now, remember, you only need to draw two of the lines, but let's check it with the third line, okay? So again, look at my iPad. Flip your iPad so that this becomes your new top vertex. The right angle becomes your top vertex, and your hypotenuse becomes your base. Start at the top vertex and draw a line down to the base. Where do all three of those points or those lines meet? At the very corner of the right triangle. Do you guys see that? This becomes our orthocenter. Oh, and I'm writing upside down. Do not ask me what the orthocenter is.
Like where on the thing?
So this is our orthocenter. Now, do you guys remember the rule for the orthocenter? For an acute triangle, where does the orthocenter lie? Inside. For a right triangle, where does the orthocenter lie? On the right triangle. Did our orthocenter lie on the right triangle? Yes. For an obtuse triangle, where does the orthocenter lie? Outside. Always use that to check your work, okay? This was a right triangle, and our orthocenter lies on the triangle. So we're Gucci Marucci, okay? 24. We need to draw an obtuse and a scalene triangle. What does obtuse mean? It has an angle bigger than 90, so draw a large angle. Doesn't matter what it looks like. What does scalene mean? None of the sides are the same, okay? So, first things first, use one color, draw your medians. So approximate the middle of each side. Again, it's not going to be perfect. And draw those points to the vertexes opposite those sides. Okay? Draw your lines to the vertex of the opposite side. And it's not drawing. There we go. And they should intersect inside or outside the triangle. Is that always true for the centroid? Yes, okay. This is our centroid. And now let's do the orthocenter, okay? So again, we have to rotate our iPads so that each side becomes a base, okay? So let's do the regular one, okay? So leave it like this, where the bottom side, do you see how that's on the bottom? That's gonna be our base. So our vertex is gonna be this one up here. Do you guys see that? Now draw a 90-degree angle. So draw a line straight down to the vertex. Down to the base. Imagine this base gets continued out like this, right? We need to draw a line straight down so it intersects at a 90-degree angle. So it's a perpendicular line. So it looks something like this. Do you guys see that? Yeah. About 90 degrees. And now we're going to turn it. So do you see that really, really long side? We're going to make that our base next. So turn it to the right to where this new dot that I'm filling in is going to be our vertex, okay? And we're going to draw a line straight down that creates a 90-degree angle. Now, those two, the way that I drew them, it doesn't look like it's going to show our intersection point. So you're going to have to continue it up in this top direction, okay? Continue it going up in this direction.
Why you go white on it, the red line and the black line together?
Because those are different, okay? The red line is the altitudes. The black lines are your medians.
No, but like these ones, like you did the other one and I was like,
Because it's, so in the previous example, right? That was a right triangle, okay? This is scalene. So the median is not going to be the same line as the altitude, okay? And then lastly, guys, turn your triangle so that your base is this side right here. And your vertex is the point on the right. Draw a nice dot at your vertex. Extend your base so you can visualize it. And draw a 90-degree line that goes through your base at 90 degrees and continues on to meet up. Approximately, you guys can probably do it better than I can with completely straight lines. They should all meet around the same point. And this is called your what? Ortho Center. Was anyone able to draw it well enough to where it's like actually looks like? That's pretty good. That's pretty good.
So,
Yeah.
that red line that's going through where the centroid is, it's not supposed to be the same line as the black one?
Very good. Okay. The line that's going through the median is not going to be the same as the perpendicular one. Okay. Down to the base. The altitude will not be the same as the median. Because this triangle was scalene. Okay. All right. For the next one, for 25, I want you guys to draw the right scalene triangle, but draw it twice so you can see the difference between the centroid and the median. Because it looks like, I think the lines are getting a little bit too confusing for us, okay? So draw two triangles, the exact same triangle for 25. We're gonna use one to show the medians, with intersecting to show the centroid. We're gonna use the other ones to show that the altitudes form the orthocenter, okay? So, for 25, we're gonna draw a right scalene triangle. So make sure none of your sides are the same length. But it needs to have 1 degree, or one angle that is 90 degrees.
Should I make mine the same so I can do? You can copy it.
Yeah. You guys can copy it. I can't copy it because I'm in explain everything. Okay? All right. So for 25, find the midpoint of each side. Again, it's going to be an approximation. It won't be perfect. Okay? And we connect each of them, right? Or no? Should it look like this?
No.
Why not?
But that's the vertex.
Has to go to the vertex. Very good. Okay. So take that point from the midpoint to the opposite vertex. So all the way over here. From this midpoint to the opposite vertex. And from this midpoint to the opposite vertex. They should all hit the same point. Do they on yours?
Yes.
Okay. What do we label this point?
Centroid.
This is the centroid. Should it lie inside the triangle?
Yeah.
Should it always lie inside the triangle?
Only for right triangle.
Unless it's an obtuse triangle, right? No, guys, the centroid is like the in-center, okay? Centroid is like the in-center. It will always be inside the triangle, okay? It'll never be outside. Will the orthocenter for this triangle be inside, on, or outside the triangle? On, because it's a right triangle, right? Yeah. Let's calculate it, okay? Use this long bottom side as your base. Draw a dot at your vertex. And then draw your altitude, which should, guys, just be a line straight down. Do you guys see that? Because it's already a right triangle, so it's already 90 degrees. Draw another point for your other vertex. Turn your iPad and draw a line straight down for your altitude. What do you notice about the last two questions we did for the Ortho Center? I'm sorry, for the first and the third question. Was the Ortho Center at the exact same spot?
Yeah.
It's always going to be where the right angle meets, okay? This is your Ortho Center. Okay? And you can check it by drawing the last altitude down to your base, make a 90-degree angle, and that point also intersects at that 90-degree angle. Did the last part confuse you guys? Okay. You're going to have to turn your iPad so your hypotenuse becomes your base. Then this is now your top vertex, right? And draw an altitude straight down to your base that makes a 90-degree angle. Okay? We're almost there, guys. An acute isosceles triangle. An acute isosceles triangle. So, for number 27, How do I know it's acute? Gabby?
Because it's less than 90.
Very good. All the angles have to be less than 90 degrees. So just draw like a regular looking triangle, except two of the sides should be the exact same length. So let's say that these two are the exact same, okay? Draw that same triangle again. And let's use the first one for the centroid and the second one for the orthocenter. Draw your midpoints. Again, don't have to be perfect. And your centroid should lie where? Mm-hmm. Will it always be inside the triangle? Yes. Regardless of the shape of the triangle, your centroid will always be inside. And then let's draw the altitudes, okay? So, make the bottom side your base. So, just leave it straight up. Put a dot at the top of your triangle. And draw a 90-degree line straight down to your base. What line did I just draw? What do I call that? No, it's not a perpendicular. Well, in this case, it's technically a perpendicular bisector. Well, what did I just draw? Zoe? Nope. Yep. The altitude, okay? Remember, your orthocenter is the altitudes. Turn your triangle so that you have now a different base. Put a dot at the top vertex and draw a different line down, creating a 90-degree angle with your new base. And then lastly, you can do the orthocenter with just two lines, but I'm going to turn it just to make sure. Make that last vertex your top vertex and draw a line down to the bottom of your base. And they all meet inside the triangle. Why did the orthocenter all of a sudden lie inside the triangle for this problem? It's not because it's isosceles. It's not because it's isosceles. It's because it's acute, okay? It depends on the angle measures, okay? So because it's acute, this is now our orthocenter inside. Guys, there's a lot to know for this test, okay? Savannah?
Are we gonna do example 3?
Yes. Okay, now, in the beginning of this lesson, okay, I did skip an example. So I want you guys to go back to that example. I believe it was on slide 12. It's called example 3.